everyone. I am Dr. Jagadha, Associate Professor in the Department of Mathematics. Today we will discuss about Stokes' theorem. In that, what is the definition of Stokes' theorem and the problem based on Stokes' theorem. First, the formula which is defined for Stokes' theorem is, let capital S be an open surface bounded by a closed curve, but the curves they are not intersecting each other. If the vector f is any differentiable vector point function, that is, this vector function at the particular point which is differentiable, then the line integral, that is the closed curve, represents the closed curve, the curve name is C, f dot dr, which is equal to surface integral curl f dot product unit normal vector, that is which plane it lies. The surface regarding which plane we are taking, that is represents ds. So line integral equal to surface integral of curl f, that is cross product. The curl f, it's nothing but del cross f dot n ds is the Stokes theorem formula, where see this curve is in the positive direction and n is the unit outward drawn normal at any point of the surface. Now the problems. Verify Stokes theorem for capital F equal to y square I minus 2xyj. That is, this is the function which is given where it is in 3 dimension. The k regarding the mutual perpendicular vector which is not mentioned in our given function. Only it is given y square I minus 2xyj. Taken round the rectangle bounded by x equal to plus or minus b. That is, plus b is a point on x-axis and minus b is a point on x-axis. Y from 0 to a. X is from minus b to b. This is the condition regarding the bounded region which is given in our question, and we have to verify Stokes theorem. So Stokes theorem, we know the formula is line integral equal to surface integral of curl f dot n ds, that we have to verify. That is both the left position which is equal to left position in value, we have to get it. So the Stokes theorem formula, which is integral over C f dot dr, which is equal to surface integral curl f dot n ds. So the curl f, we can take it, that is I, j, k, dou by dou x, dou by dou y, dou by dou z. For here, in our function, I regarding which is there, y square, which is written here, the j, the mutual perpendicular vector, for that minus 2xy, it is written. Regarding k, there is no term at all, so it is treated as 0 and we have to put it 0. Now curl f we have to find. So this determinant we have to find. So the determinant, first this position is a sign of positive. When we are going to concentrate this I, this particular position, then regarding the row and column, we will neglect it. This cross product, we have to do it. So, dou by dou y of 0. Here there is no y term at all. Moreover, that is a 0. So, here the value 0, we got it. Here, there is no, we have to do dou represents differentiation with respect to partial. So, dou by dou z. So, here we have to do the differentiation with respect to z partially, but unfortunately there is no z term. So, here it is 0. But here minus is there. How it has become here plus? That is, this cross, that value, that is this one, minus this cross, this minus the formula minus. Here we got it as 0, so minus into minus, that it has become plus 0. So regarding this we completed. So the next one is J vector. That is, this particular position is, it has the sign minus. So when it has the sign minus, that it is put here, minus j. This column, this is neglected. And the remaining one, we will do the cross multiplication. Just I will put the tick. These two we have to do it. It's nothing but a 0. In the formula, between that minus is there, that minus. And this we have to do partial differentiation, but there is no z term, so it is 0. So the last one is k. That particular column, particular row, we have to neglect it. So we have to do the cross multiplication. This cross we have to do it. With respect to x, we should do it. So the x differentiation is 1. 1 into minus 2y. Here is there. And formula 1 minus sign is there between. And this we have to do. This we are focusing. This we have done it. That is minus 2y. This we have to do it. Y square. That is 2y. But in the formula itself minus is there. So minus 2i. So completely this I and j, they are vanished. So minus 2y, minus 2y, minus 4yk. Now this curl f we completed. For the given surface S, it's an xy plane. So when xy plane is there, the z dimension, that's from which the unit normal vector k, which is perpendicular, which is normal to our xy plane, that is our surface S. So we want it now, curl f dot n. Curl f, already we got it just now. We did the determination. The determinant, we got it minus yk. So the determinant, the value is minus yk. And our unit normal vector is k. The dot product k dot k, it's nothing but 1. So 1 into minus y, which is minus 4y. So the surface integral, the formula is double integral s curl f dot n ds. So the double integral s minus 4y dx dy. Now our xy plane. So the x from minus b to b, this is the condition which is given in our problem, that is x equal to plus or minus b, y equal to 0 and y equal to a. This is the bounded region condition which is given in our problem. So x we have taken the interior integration, the limits from minus b to b, whereas the outermost integration from 0 to a minus 4y dx dy. Here, which is here clearly it is there, that is the interior integration we are going to focus. So with respect to x we are going to do, so better this minus 4 we have taken out. Only in y also we can take it out, nothing wrong in it, because we are going to do with respect to x. So y is treated as same constant. Dx, the integration is x from minus b to b. This dy and this integration is as it is. Now, minus 4 as it is, this integral as it is, this dy also we didn't touch, we have written as it is, seeing the previous step. Now, the limits we have to substitute. Upper limit is b, the lower limit is minus b. That is, in the place of x we have to substitute. We substituted, we got it by. This is limit formula sign, and x place will substitute to minus b, so minus by dy. So minus minus put together plus. Here we got it plus 2 by. Outside also minus 4 is there. So we can see it here. This is the last step. So put together the simplification, we got it minus 8by dy from 0 to a. Now this minus 8b we wrote it as it is. Y dy, this is the integration we have to do it. Very simple integral formula, x power n dx. Y the power is 1, so n is taking the value 1. So y power 1 plus 2 divided by 1 plus 2. So y square by 2 from 0 to a. Now, in the place of y, before that, this we can simplify. So it is becoming minus 4b. Now we will substitute in the place of y the upper limit value a. So when we are substituting upper limit value, it is becoming minus 4a square b. The lower one, if we substitute in the place of y, the value is 0. That is what we neglected. So this we found that surface integral, that is curl f dot n ds. We found the value minus 4a square b. This is our given function. And so here actually only one equal sign, that is a typing, one mistake. That is a line integral which is equal to surface integral curl f dot n ds. This is the bounded region which is given, that is x equal to plus or minus b, that is minus b to b, x is taking the value and y is taking the value 0 to a, for which we have to find now line integral. So this side we got the value minus 4a square b. Now this line integral also we will evaluate. We should get minus 4a square b. So this is the bounded region. So from this it is xy plane. So we have taken x, y. Looking at the bounded region condition, x and y. This is our O. That is here 0 is there. We are D and points we are making. There is a point at x-axis, that is in the negative direction. There is a point. That point we know it minus b. That particular point, that is minus b, which lies on x-axis in the negative side, that point we are naming as D, and there is a point B in the positive direction, that is in x-axis. That point we are naming as A, and Y from 0 to A, that is in the y-axis there is a point A. So one straight line is going to come. So that straight line, only this one, it cuts at here. There is a point y equal to A, it is there. Then this is minus B, then this is nothing but, we can see it. So the direction which are given here, it is actually, if it starts from here, the direction we can see it here, it's forward. In the positive direction only it will be moving here. That is the starting point. It coincides with the ending point, terminating point. It is a closed curve. It is a closed curve, and minus B which lies on x-axis, B which lies on x-axis. When the points this lies on x-axis, y equal to 0, and y, that is this point is B is there. There is a point, then automatically y is 0. Here minus B is there, then what about y is 0? A point which lies on x-axis, then y equal to 0. That's what it is mentioned. Now, here you can see the points. So, DA, CD, closed it, y equal to 0, and x equal to B, because if it is moves y direction, what about x value? X equal to B. We can see it here. This is B comma 0. This is B comma A. We can see the direction of the arrow marks, which is given. We can see this slide, the bounded region condition. The points we can see it. That is minus B comma 0. That is a point of our D. And the point of A is B comma 0. And the C point is minus B comma A, and this point is B comma A. So it is compulsory from here D to A to B, B to C, C to D. So the 4 along we are going to evaluate the values, that is along DA, along AB, along BC, and along CA. These 4 values we have to add. We must get, after addition, the result it should be minus 4a square b, because already we evaluated the surface integral curl f dot n ds, which is equal to minus 4a square b. Now our line integral also dA, AB, BC, CD. If we add, we should get minus 4a square b. Now we can see here, that is the line integral over C f dot dr is the line integral formula. This line integral formula, according to our problem, dA, this is the first line integral, next AB, second line integral, next BC, our third line integral, next CD, this is the fourth line integral. In this integral, to do f dot dr is required. F is our vector point function. That is, our problem vector function is y square I minus 2xyj, this is the dot product, into r vector, it's nothing but xi plus yj plus zk. So dr, it's nothing but dxi plus dyj plus dzk. Now we have to do the dot product. So the dot product is I dot I, that is y square dx. Next to this we have to do it minus 2xy dy, but there is no k term, so we can neglect it. So we are getting now, after doing the dot product, our f dot dr is y square dx minus 2xy dy. Along dA we are. Now along dA means here it moves in x direction. So when the particle, suppose if it is here from the point D, it moves to A. That is x direction it moves. X varies from, there is a motion, x varies from minus b to b. That is integral over the value, the range value integral minus b to b. So this is over. Then what about y? Y equal to 0, dy equal to 0. These values we have to substitute in our f dot dr. So substituting, this is getting vanished because y term is there. This is also getting vanished. So this we already wrote it. That is, when the particle it moves x direction, x, that is x direction, there is a movement at a distance from where to where, minus b to b. So we wrote it x varies from. Now our f dot dr, which is equal to 0. So no need to find the integral at all along dA. So one direction, our dA we completed, the value is 0. Now we are at the point A. From A to, we are going to move to B. AB is our along the line we are going to calculate. So the line integral along AB, that is, which is in y direction. So when it is in y direction, there is a movement, there is a motion, there is a distance from particular point to another point. The movement it is there, that is from 0 to A, because we are moving towards y direction. So the integral over 0 to A we are moving. So we can see it here. So we can, all the points are given. So we completed this one just now, that we got it 0. Now we are in this domain, AB domain. Here we are moving y direction. There is a movement at a distance, that is from starting from 0 to A, the integral over. And what about x? X is b, dx equal to 0. Every integral finding, we have to find f dot dr. Already in advance we found it, that is f dot dr, that is nothing but y square dx minus 2xy dy. Then AB, according to that, what is the condition that we are going to write? That is along AB, it is in y direction. So y varies from, we can see it, 0 to A. That's what it is written here. What about x? We can see it. I am circling x equal to b. And dx, the differentiation of any constant, which is equal to 0. These values we have to substitute in our f dot dr. So completely this is vanished. Dx equal to 0 and x equal to b, this is taking the value b. So from 0 to A, minus 2by dy. We can see it, minus 2b, it is written outside. Y it's nothing but the integration is y square by 2 from 0 to a. So what is our upper limit? The upper limit is a. This 2 is getting cancelled. So upper limit minus lower limit. Lower limit anyway is 0. We will neglect it. Then y is taking the value of upper limit a. It is becoming, already square is there, a square. So 2 getting cancelled. So minus a square b. Now, so first we did dA, the value we got it 0, and AB just now in this slide we have evaluated, we got it minus a square b. Now we are at b, from B2 we will move to C. So we can see the points. So this completed, this is also we completed. Here 0, here minus a square b. Now we are going to focus along BC. So we know it, every the line integral, that is a formula, f dot dr is there. Already we did in advance, f dot dr, that each slide we are writing. So y square dx minus 2xy dy. From B to C we are moving, it is in the x direction. X direction. So x varies from B to minus b. That is integral over, the BC is there, integral over minus b to b. Sorry, b2 plus b2. From here, B to C we are moving. So B is here, B is there. So B2 minus B, we have to do it. We can see it here clearly. So B2, here B is there. B to C, here B is positive from here to here. So B2 minus B, we are moving. That's what here also it is there, B2 minus B. And what about y? We can see it, a is there. That only it is written here, dy equal to 0. This we have to substitute in our f dot dr. So dy equal to 0, completely this is getting vanished. So here y is taking the value a. So a square dx. So a square dx, we have to do the integration. A square is as it is. Dx, that is the integration is x. So b2 minus b. So upper limit is minus b. Lower limit is b. We will substitute a square, upper limit minus b, limit formula minus, the lower limit is b. Now minus b, here minus b, minus 2b into a square minus 2b a square. So this integral along BC f dot dr, which we calculated and we obtained the result minus 2b a square. So the last point is, we can see it, we are here, C, the point, from the C point to D we are moving, that is starting and terminating point, both coincide, it is a closed curve. Then here CA, it is in y direction. When it is in y direction, y varies from A to 0. That is in the coordinate, y position is A, here the position is 0. From integral over A to 0. What about x? X is nothing but minus b, dx equal to 0. It is a very simple simple way, looking at the diagram, we can write it. So now this we got the value 0, this we got it minus a square b, this minus 2a square b. Now we are calculating along CD, that is f dot dr. That already f dot dr, which is here, that is y square dx minus 2xy dy. Along CD, that is x actually playing the value, the role is minus b. We can see it here, minus b. So dx, which is equal to 0. Now y varies from a to 0. We can see very clearly a to 0. So integral over CD f dot dr, which is equal to integral from a to 0 to b y dy. This how we obtained, that is, this values we substituted in our f dot dr. So when we are substituting here dx, which is equal to 0, so completely this is vanished and x is replaced by minus b. So minus 2 into minus b, we got it 2b dy. Now this we have to do the integration, that is 2b, which is written out, y dy. So y integration is y square by 2. It's a simple integral formula. Integral x power n dx equal to x power n plus 1 by n plus 1. Our n is 1. So y power 1 plus 1 by 1 plus 1, y square by 2, and the limit is from a to 0. This 2 and this 2, they are getting cancelled. B is outside. Only in the place of y, we are going to substitute the value because we did the integration with respect to y. So after substituting the upper limit, the limit formulas are upper limit minus lower limit. So the b2 to cancel, the b is written as it is, and y place we wrote it the upper limit. Totally it has become 0 limit formula, and y place we substituted the lower limit value a. So a square, which is equal to minus a square b. So the first integral we got a 0, the second one minus a square b, the third one minus 2a square b, the last along CD minus a square b, we got it. So we can see it here. This is our given question vector point function, that is f vector, which is equal to y square I minus 2xyj, and the bounded region which is given x equal to plus or minus b, that is minus b plotted in the x-axis negative direction, plus b we plotted in the positive direction of x-axis, and y from 0 to a. With this bounded region, we got a geometrical figure. Before that, this is the formula for Stokes theorem, that is line integral. Here the closed curve C, which is nothing but f dot dr, which is equal to surface integral, that is capital S curl f dot n ds. Here this f, we did curl f. For that we did gradient cross f we found, dot n. it is in our xy plane. So xy plane, the next one is k. Here we can see it. So here this we did the calculation. We obtained minus 4a square b, and whereas the line integral we did the 4 directions. That is, from dA we did the calculation. It moves in x direction. X varies from, you can see the coordinates. Here the coordinate is minus b comma 0. Here b is 0. Here there is a point A on y-axis. Here is there our y-axis. That is the reason this point is BA. Here the point is minus BA. We named it as B and C. So the DA direction along x direction, x varies from minus b to b. We substituted according to this f dot dr, what is the value. Finally, the integral totally along dA, we got it 0. From a to b, we moved it. It is in y direction. So y varies. That is the integral 0 to a. This we did. This we did. And we found the value minus a square b. From b to c, we moved it. We have to be very careful. B to C we are moving because this arrow marks, it is anti-clockwise direction it moves. No positive, negative direction not there. Towards positive direction it moves. So we can see it here starting, moves, it moves, and it will comes to the starting point. That's the reason it is a closed curve. Starting and terminating point should coincide. Here also the symbol it is there, integral over, it represents it is closed curve. And from BC, it is the x direction. From B to A, integral over, we calculated minus 2a square b, and from C to D we moved it, and it is in y direction, A to 0 we calculated. The final one we obtained minus a square b. So here this is the f dot dr, and in this function only all the values we substituted. This is the along DA result. This is the result of along AB. This is the result of along BC. And this is the result of along CD. So we can see it once again. So completely which is given here. That is even the line integral. The result we obtained minus 4a square b. So line integral which is equal to surface integral. Line integral that is over CF dot dr which is equal to surface integral curl F dot n ds. Our ds it is in xy plane. So we can see very clearly this is the formula and we verified it, that is Stokes theorem is satisfied. We will move to the next problem, that is using Stokes theorem evaluate the integral. They are not telling to verify. They didn't tell. If it is verify, just know what we have done the previous problem, that is a formula integral over c f dot dr. We have to calculate the result what we are obtaining. It should equal to our surface integral curl F dot n ds. It should match. But here they told only using Stokes theorem evaluate, that is integral over c f dot dr, where our vector function is 2y square I plus 3x square j minus of 2x plus z k. And C is the boundary of the triangle whose vertices are. That is, some vertex here. This is one vertex 0, 0, 0, another vertex 2, 0, 0. The last one is 2, 2, 0. These vertices, if we are noticing, this is x is place, and the second one is the place of y. Third one, it is a place of z dimension. Completely, the z dimension, the value is 0. So the clearly from the vertices, the points which is given in our problem, the first one is 0, 0, 0. Second one is 2, 0, 0. The third one is 2, 2, 0. From which we are getting the clear picture about it. The given problem is xy plane because the last one is 0. So, and function also is there. We have to using the Stokes theorem, we will evaluate the integral. Now we will move towards the solution. Now the Stokes theorem formula is, so we can see it here. This is our Stokes theorem formula. We know very well because in detail we are discussing through this video lecture. That is line integral, which is equal to surface integral of curl f dot E and ds. Our f is playing the role of vector point function. Curl is nothing but a gradient cross. This what is the function, and dot product n is nothing but normal vector to our surface. ds, it's nothing but the function which lies in which plane that it represents. Now, this is our given function, and this is the point, the coordinates of 3 dimension which is given. It is not now 3 x, y, z is there, but z, that particular dimension, totally the value is 0. So now first, that is line integral, which is equal to surface integral of curl f dot n ds is our formula. First we will find out what is curl f. So the curl f, it's nothing but I is there, j is there, k is there. So dou by dou x, dou by dou y, dou by dou z. Here if you're noticing, dou by dou x, it's nothing but our 2y square, which is written here. Dou by dou y, which is nothing but 3x square, that is also placed here. The last one is k. Here that is minus of 2x plus z. Here minus we are taking inside. So minus 2x minus z. This we have to find determinant. So when we are focusing on determinant, first this position is I. That is, this particular place is positive, that is plus. So we will neglect this row and we will neglect this column. So the remaining one, we have to do the cross multiplication. That is this cross and minus of, that minus is related to formula. Here when we are doing this cross, there is no y term at all. So we can see that is the reason here 0 is there. And this cross to be done, minus of that cross value. So here also there is no z term. So that's what here also 0, completely the I direction. That is the x direction towards a mutual perpendicular vector I. It has become 0. So the next position is j vector. That is, this position is minus. So minus j, the particular row and column, we will neglect it. So where I am putting the tick, we will do the differentiation partially. So the dou represents partial differentiation we are concentrating. So in this particular one, where is the x variable? The x variable is -2. So we will put tick. And these two to be done. But here 2y square is there, but we have to do partially with respect to z, we have to do it. But there is no z term at all, so it has become 0. Now the last one is k. So the particular row and column to be neglected. So here we have to do cross. That is 3x square is there, that we have to do partially differentiation. So it is becoming 6x. Now this we have to do cross. 2y square. So the differentiation is 4y. Then from where this minus sign? Minus sign, when we are doing the determinant, this cross, the value that is 6x minus this is related to formula, and this cross value to be substituted, that is 4y. That's what here it is there. This minus is related to formula. There is no connectivity of, that is a problem terms, there is no connectivity. So now we will do the simplification. This mutual perpendicular in the direction of x completely vanished. -2 minus j. -2 minus j, it has become 2j, and k is there of 6x minus 4y. Now, since the z coordinate of each vertex of the triangle is 0, here, that's what here, what it is written, here we are noticing the coordinate, the z, that is becoming 0. So the triangle which lies in the xy plane. So if it is xy plane, totally ours is 3 dimension. The surface is xy. Then another side, it is in z dimension, from which the force, the normal vector, which is perpendicular to our xy plane. So the particular z dimension, our normal vector is k. That's what it is written, n equal to k. Now, to find the formula, that is the surface integral over S curl f dot n ds, we want it. Our ds is now xy plane. So in the ds, we will replace it dx dy. Before that, to substitute in the formula, we will find curl f dot n. So our curl f, just now we did the determinant, the value is 2j plus 6x minus 4y of k dot n. So 2j plus 6x minus 4yk dot, our n, the mutual perpendicular vector is k. So the dot product, this is neglected because the dot product, we know it, j dot j exists, but there is no j dot j, j dot k, so it is become 0. Only the dot product k dot k exists. So 6x minus 4y is the result. That is only curl f dot n value we obtained, 6x minus 4y. Now, considering the triangle in xy plane. So we can see it here, there's 2-3 slides. It's only one equal sign. This is the vertex. Yeah. That is, we are going to focus. This is using this vertex. We will frame the triangle, and we can see it here. This represents x, we know it. So there is a point in x-axis 2, it is there. That's what here, that we named it as a. The point is 2 comma 0, and we can see it here. We joined it. This is 2 2, that is x is here, and if you are noticing here, y place also 2 is there. From the vertex we can see what are the values of the coordinate vertices which are given in our problem. This place y, that is 2, is there, so 2 2 here. So we join that name, we have given b, so AB. We are noticing here x 0 to 2, y also 0 to 2. So we can write this is x equal to y, and the direction, we are moving from O to A to B we are moving, and B to O we are coming back. That is the starting point. We are coming as a terminating point, coincides. It is a closed curve. This curves also, there is no intersecting at all, for which the Stokes theorem fits. Now, equation of the straight line along this BO, this one, BO is, now this is, we know it, our Stokes theorem formula. By Stokes theorem, we know it, the line integral which is equal to our surface integral, that is curl f dot n ds. We can see it, the same figure which we explained just now, it is kept here. Curl f dot n ds, again which is written here, that is curl f dot n, what we obtained the result which we can list, we have to put it here, that is 6x minus 4y, and ds, that is our x and y plane. So that is the reason it is written here dy dx, and dy dx, then y from where to where? Y from, here we can see it, here y is from 0 to where it touches. This is the straight line it touches. So y equal to from 0 to x. So when we defined the interior integration with respect to y, we have to do the integration with respect to y. The outermost one is x equal to, so we can see it here, this one, from 0 to, here our x is 2. So it moves x direction from 0 to 2. That's what the outermost integration which is written from 0 to 2. So we will do the integration now. So the integration is, here we have done it with respect to x. 6x we are doing with respect to y. 6x is written as it is. So dy, the integration is y. Minus 4, we wrote it as it is. Here y power 1, simple integration. So y power 1 dy, it's nothing but y square by 2. Simple integral formula that we know it. X power n dx, x power n plus 1 by n plus 1. Our n is 1. So here we did the integrated result. This 4 and 2, we will cancel it. So this is the last step. So we did the cancellation. Before that, here we can do it. It will become 2. So in the place of, here we did the integration with respect to y. So here y is replaced by x. 6x into x, it has become 6x square, and this minus sign as it is, and y square. Already 2 is there. Y is replaced by x, so it is 2y square. So completely the limit formula, that is the upper limit, the value that is in the place of y, we replaced x, we obtained 6x square minus 2x square, and this is the limit formula, and we are going to substitute in the place of now y the value, the lower limit value 0. So where I am putting the tick, there is the y terms are there. So the lower limit value, if you substitute completely, the lower limit is vanished, doesn't exist. So that's what here we put it, the value is 0. Upper limit substitution is completed. So the interior integration with respect to y integrated, substituting the limit values also over. Finally, we got the result 4x square dx. Now we will move to our outermost one. So the outermost one is integral from 0 to 2. This part is 4x square dx. So this x square, simple integration, 2 plus 1 divided by 2 plus 1. 4 is written as it is, x square, the integrated one, the value x cube by 2, upper limit value 2, lower limit value is 0. So the substitution is, now in the place of 2, we are going to x, in the place we are going to substitute the upper limit 2. So 2 cube, 8, 8 4s are 32 by 3. This is limit formula, and x place we substituted the lower limit value is 0. So 32 by 3 minus 0, it's nothing but 32 by 3. So we will come to a conclusion of this topic, Stokes theorem. First, we have taken the function f y square I minus 2xyj, and this is the bounded region which is given, that is x equal to plus or minus b, y equal to 0 to a. It's a very beautiful problem, that is plus or minus b. So minus b to b, x direction, minus b which is plotted in the negative side of x-axis, plus b, positive side of x-axis. And what about y? From 0 to a, verify Stokes theorem. So we know it, this is the Stokes theorem formula, that is integral over c f dot dr, which is equal to surface integral curl f dot and ds, for which we have drawn the figure, looking at this bounded condition here. This is nothing but here the minus b is there, it's a point, and here plus b is there, and here that moves y direction, that is here the point is b comma a. So here the point is minus b comma 0, here the point is b comma 0. That is when it moves in x-axis, y is automatically 0. That's what it is written. And here it moves in y direction, the value of x equal to b. And there is a point a on y-axis, here it is there. And one more thing, we noticed it, when it moves, this point is minus b comma here a. It moves in positive direction, that is from d to a to b, b to c, and c to d. We calculated, when we are calculated the dA, the value which is 0, this calculation minus a square b, and this calculation minus 2a square b, and this calculated value is minus a square b. Put together left line integral and surface integral. Both the values are equal and we proved the Stokes theorem is verified. Next, we have taken a next problem for which the function is 2y square I plus 3x square j minus of 2x plus zk, for which the vertices are the first one 0, 0, 0, next 2, 0, 0, the last one 2, 2, 0. It's a very beautiful thing looking at that. Here, the looking at the function which is in 3 dimension, but the vertices, what are the coordinates are given from which we understood it is only xy plane, because we have noticed the z dimension, the value which is given 0, and from which the coordinate what is given, with that help we have, so completely here it's only one equal sign, it is a typing mistake. Here we have drawn completely looking at the vertex. This is the figure which is drawn, and here also the directions we are noticing. This is the name O, the point is 0, 0. Here the point is a point A 2, 0, and the top one, the point is B 2, 2. This is nothing but the straight line y equal to x. The point, the arrow marks, it shows that is a particle moves from O to A to B, B to O. That is, it is a closed curve. That is, the coincides starting point and ending point. That is, the terminating point coincide, and we obtained the value 32/3, and we didn't do here only one side, we proved it, that is 32/3. So just they told the second questions only evaluate. So the result we produced it, that is 32/3. Thank you very much to all.
Like, share and subscribe. Hit the bell icon for more updates.